We're going to continue talking about hypothesis testing today. So remember our steps for performing a hypothesis test. This is what we've talked about all through Chapter 10 so far. We start by stating the null and alternative hypothesis. We determine what type of test to use. So far we've talked about a z-test or a t-test. Those have been our two options so far. And we state the level of significance. Then we calculate the sample statistic or p-value. P-values are most common. That's what we're going to tend to do from now on anyway. So we're going to calculate our p-value, and then we draw our conclusion. So we decide, do we reject the null hypothesis, or do we fail to reject the null hypothesis, and we interpret it. So same 4 steps are going to continue today. But now we're going to look at hypothesis tests for proportions. Everything that we've done so far has been means. We're looking at, is the mean number of pets, one study said the mean number of pets in Bryan was 2, and someone else claims that it's more than that. So that was a mean. But now we're going to look at population proportions. So maybe something like someone wants to say that the proportion of people in Williams County who vote Republican is this amount, and someone believes that it's actually higher than that, and you want to test that. So we're dealing with proportions now. We can do proportions. This is the criteria that we need to have. We need to have all possible samples of a given size have an equal probability of being chosen. That's our definition of simple random sample. We have to have a fixed number of independent identical trials. There can only be 2 outcomes, one with a probability p and the other one minus p, so no other outcomes. And then this last one is really key, and we're going to do quite a bit checking on this. Before, we've always said the sample size needs to be at least 30 or an approximately normal distribution. That is not true for population proportions. We have to have it large enough such that n times p, so n is the number of samples, and p is our probability. So n times p has to be greater than or equal to 5, and n times 1 minus p has to be greater than or equal to 5. So as long as your sample size is big enough that both of those things are true, you can use this. Oh, I didn't put the box around that. Okay, and we'll be testing for that quite a bit today. When we do this, we're going to calculate a test statistic. So we have a new formula for finding our z. When we're doing population proportions, there's no sigma involved, so we always get to use z. So you don't have to decide do I know the population standard deviation? Doesn't matter. Okay, so z is going to be p hat minus p over the square root of p times 1 minus p all over n. Remember, p is the population proportion. P hat is the sample proportion. And we've dealt with both of those before, so that should be pretty familiar. So what we're going to do first is we're going to look at these scenarios and just decide which type of distribution should be used. Because that's going to be really the key thing that you're going to be doing from here on out in Chapter 10 is we've learned all of these, we're learning all these different types of hypothesis tests. You have to decide which one's the best to use when. All right, so at least 15% of listeners of nonprofit radio stations generally favor commercials for other nonprofit organizations on the same station. A local nonprofit radio station believes that less than 15% of its listeners favor such commercials. The station plans to survey a simple random sample of 50 of its listeners to test this claim. All right, so they are thinking about there's 15% of listeners. They're claiming that they like nonprofit, and they're testing that it's actually less than that. Okay, since 15% is a proportion, that is not a mean number, we are hoping to use a 1 proportion z-test. Later on, we are going to get a 2 proportion test, but since this is only 1 sample, it's a 1 proportion z-test. So hopefully we can use this. We need to check both NP and N1 minus P. Okay, because I think we've met all the other ones. We have a simple random sample. We have a fixed number of independent identical trials. We're just going to ask these people. There's 2 possible outcomes, like do you support this or not? So as long as this last one is met. So n is 50. We're planning to talk to 50 people. And our proportion is 15%. So n times 0.15 is 7.5. And then n is 50, and 1 minus 0.15. And when you multiply those, I think you get 42.5. And we're looking at these two numbers. They are both greater than 5, so we can use this. This is a 1 proportion z-test. All right, let's check out the next one. The college paper reports that at least 10% of students turn off their cell phones during their classes. Aggravated with the number of cell phones that ring during his class, the professor believes that fewer than 10% of his students actually turn their cell phones off during class. He plans on testing this claim by asking a simple random sample of 20 of his students to show him their cell phones one day during class. All right. Again, we are talking about a percentage, a proportion of students who turn off their cell phones. So we are hoping to use a 1 proportion z-test. Hopefully. We're going to check and make sure all of our conditions are met. So let's see. Simple random sample, we have that. Fixed number of independent identical trials is just asking 20 different students, so that's fine. 2 possible outcomes, either your phone's on or it's off, so that's good. So now we need to check if our sample size is large enough. NP and N1 minus P. So he is asking 20 students. Our proportion is 10%. And when he does that, he gets 2. And remember, this needs to be greater than 5. So this, I'm not even going to bother to check the other one. This does not meet our criteria for the 1 proportion z-test. So we're going to say 1 proportion z-test cannot be used because the sample size is too small. Now, if the professor wants to go on and carry on the study, that would be totally fine. He just needs a bigger number here so that when he multiplies it by 0.10, that he would get at least 5. So maybe he needs to bump up to 50 students rather than just 20. Okay, so what he has proposed isn't going to work, but that doesn't mean, there's the bell, that doesn't mean it won't work without some adjustments. All right. The last one, the mean amount of rainfall in the southern part of Texas during the month of September is commonly believed to be no more than 3.02 inches. A meteorologist claims that the amount of rainfall this September has been higher than normal. He tests his claim by measuring the amounts of rainfall in a simple random sample of 12 locations across the region. Assume that the population standard deviation is unknown and the population distribution is approximately normal. All right, the key on this one, mean amount of rainfall. Okay, this is not a proportion, this is a mean. So if you're dealing with means, this is either a z-test or a t-test. So we have to decide which one. And right here, assume that the population standard deviation is unknown. Well, since it's unknown, this is going to be a t-test. Okay, so we'll have to make adjustments for that. But this was just to kind of give you an idea of how you read through these and decide which tests that you're going to be using. So again, so far we've done a z-test, a t-test, and now we're looking at a 1 proportion z-test. We'll check out how to actually do these problems in the next video.